Welcome to Engineering Visualization channel. Today we are going to solve model question paper 5 VTU computer aided engineering drawing. Okay, here in this question they have given question number 1, it is rectangular lamina, question number 2 hexagonal prism it appears to be, and here question number 3 they have given to complete the orthographic projection of this object. Okay, so for this particular problem I have done the top, front and side views, so please go through. And problem number 4, it is cube problem. Okay, you can see this. In order to see more videos like this, you can subscribe to my channel and hit on the bell icon and watch till the end. Width give 30 and height 20 and place it with the shorter edge here on the VP plane. Okay, so measure the dimensions. Okay, write down the notations and draw the projection lines to complete the top view. Okay. So here B and C are not visible, that's why B and C written within brackets. Select the top view, go to move command, creates a copy of it and slide along the line, and now we can give the inclinations. So inclination to the VP. So here I'll give angle of inclination 30 degree. Okay, so inclination below the XY line means minus 30 we have to give. Okay, draw the projection lines to complete the second position front view. And write A dash, B dash, C dash and D dash. Go to thick line, okay, second position top view completed, and trim it off these extra lines. You can see now longer side of the plane is inclined at dash degree to VP. That means we should take that longer edge and we have to give the angle of inclination here. First I'll be drawing an angle line. Okay, angle of inclination here I'll give 45 degree. I'll select this second position front view. Okay, creates a copy of it and select the vertical edge here. I'll select this B dash, go to rotate, select this B dash to C dash and place it on the angle line. Then project downward to complete the final position. Complete the final position by joining with the thick line So this completes the problem. Problem number 6 from the respect to edge here. So hexagon of dimension 25. So make sure this icon maintain relationship has to be on. Then use polygon by center, 6 sides. Okay. With respect to edge. So give the naming C D E given in bracket. After this, we draw the thin lines to find out the center of the axis. Okay, that is diagonals we are going to draw. It is O. Okay, now here axis length is 15. So we are able to see B dash, C dash, D dash in bracket. Able to see O1 dash and dash and O dash also not visible. Okay. So now 45-degree inclination to HP. So we are going for base edge inclination. 19 minus 35 equal to 45. So we have to incline this with respect to the base edge. Okay. Angle of 45 degree. Then extend extend command can extend the axis and find out the angle of inclination. A1, E1, C1. So here projection line.
ಸರ್ ಎಲ್ಲಿದ್ದೀರಾ ಹಲೋ ಸರ್ ಒಂದು ಇಮೇಲ್ ಫಾಲೋ ಮಾಡ್ತೀರಾ ಅದು ಎಲ್ಲಿಗೆ ಕಳಿಸೋದಕ್ಕೆ ಅಲ್ಲ ಸರ್ ಅವ್ರಿಗೆ ಇದು ಮಾಡ್ತೀವಿ ಮಾಡ್ತೀವಿ ಪ್ಲೀಸ್ ಒಬ್ಬರು ಪ್ಲೀಸ್ ಅಲ್ಲ ಸರ್ ನಂಬರ್ಸ್ ಹಾಂ ಸ್ವಲ್ಪ ಓಕೆ ಪರವಾಗಿಲ್ಲ
So first we have to construct an outer boundary line. This section of this is visible from here. Okay. And this rectangular face also visible. This hexagonal base not visible from the top view, so it is written with the dashed line. Okay. Here from this slanted rectangular it's also not visible. You can show part of the line here from here to here. Now 40-degree angle line. So angle we have to give that is 20-degree angle. Minus
ಬಂದು ಸರ್ ಬಂದು ಥ್ಯಾಂಕ್ ಯು ಸರ್ ಆ್ಯಕ್ಚುಲಿ ನಾನು ನಡೆಸ್ಬೇಕು ನಮ್ಮ ಇವ್ರು ನಡೆಸ್ಬೇಕು ಸರ್
you have to have here 40-degree. 40-degree. So this is 40. Then we have to select it. Okay. Axis line here. So select this diagram to create it. So I can take it a little lower.
can give the naming. Another projection line. V1 dash, V1 dash. So here are two nearest point to X velocities E and F. Okay, E to D, E to F, and F to J, and F to F1. Like that, first we construct the dashed lines. Now rest of the diagram it is written with a continuous line. The slant edges. Finally, axis.
Good morning, all of you. So you can see in this, this is what the isometric component given. So we have to construct the isometric views, that is front view, top view and side view. You can see this is your isometric. Isometric means it is nothing but the 3D view of the component, okay, wherein it will show the dimensions both in X, Y and Z direction. Okay, isometric means it is a 3D component. Okay, but the orthographic means, so it is the individual views. You can say the top views, side view and front view. So the separate views what we get, that what we called as your orthographic views. Okay, here we need to convert these isometric into orthographic. Okay, that's what we have to do in this problem. Okay, you can see there is a front view exists, there is a front view, side view and top view exists. So we have to analyze each of these views and we need to construct all these front view, top view and side view. Okay, they have mentioned in the question front view looking from X means that is your front view. So then you can see there is a top view exists. Okay, and there is a side view. So we will be constructing each of these views one by one. Okay, so first I'll be constructing XY and X1 Y1 line. So thereby I'll be dividing the regions for both top view, front view and side view. Okay, so here I'm drawing XY line. So I'll be mentioning XY. Okay, I'll be mentioning X1 Y1, that is profile plane here. Okay, that is X1 and Y1. Okay, now we need to analyze. So we can write this here. Here I will be constructing the front view. That's why I've written FV. And here I will be constructing top view. And here side view. So that's what the short notations. Otherwise I will write the full thing. Front view. Okay. Top view. Top view. And this is our side view. Okay. Now we have to analyze the isometric. You can see in this isometric. So this is our front view. So which are the faces visible from this front view? We need to analyze. I will write it. This is our front view. So this is our top view. So we need to look at this this component from the top view. That's why it is top view. And this is where we get the side view. Okay. This is we have the side view. Okay. So you can mention the shortcut also. Okay. In the next problems, I'll be mentioning shortcut. That's why I'm writing there. Okay, you can analyze from the front view which are the faces visible here. You can see I'll be constructing there front view, top view and the side view. You can see the front view and side view always adjacent to each other. Okay, adjacent to each other, and then top view and front view will get in a vertical collinear line or a plane. Front view always adjacent to the side view. In order to connect the top view with the side view, we draw 45-degree angle line. Okay, so now I'll be analyzing the front view. So to analyze the front view, which are the faces visible, I'm going to shade it. Okay, I'm going to shade it. So this is how it is easy for us to identify which are the faces visible from the front view. You can see that L shape is visible from the front view, and then this rectangular face also visible from the front view. I'm shading it. Okay, and this face also visible from the front view. Okay, so these three faces are visible from the front view. We need to draw. You can see the length of it. It is having 104 mm, and the height it is having 48 mm. So that means we can construct one rectangle with 104 and 48 mm with thin lines. Okay, so I'll be drawing a line here, horizontal line for 104 mm. You can see all these dimensions were in mm. Okay, so 104 mm. So the height here we should get, that is 48 mm. Okay, so mention 48. Okay, and same thing we can do it. As I mentioned, we'll be constructing a rectangular face. From there we are going to dark the things. Okay, okay, so now you can see, analyze this front view. Okay, front view. So we need to have a dimension here. You can show the dimension, which we have constructed a rectangular face here. Dimension of 104 here. We can mention that. Okay, 104, and this is we have 48 mm. Okay, height. Okay, so now you analyze the diagram. So in the diagram you can see the L type shape component we should get, and it is having a height of say 16, and from there it is having a dimension of say 24. So we can mark here 24,
and then 16, like that we can do. So first I will be doing 24, marking for 24 mm, and then vertically downward I will draw a line. So mark for 24, okay, then vertically just draw a straight line, okay, and then here from this end we should exactly cut it at a height of 16, okay. So here also I will drawing one line horizontally, okay, okay, and then we need to extend by 16 mm as it is mentioned. It's like steps were there exactly at 16 mm height, okay. Can construct that. So you can see here we will erase this part. It is similar to L shape, okay, we will erase that. Now we should dark the faces which is exactly visible from the front view, okay, we should dark it. So these are the faces. This is how it is exactly look like in front view, okay, in the front view. So we should dark that. Okay. Okay, now we need to construct can show the dimensions, okay. It is so showing the dimension is, so it is having dimension of 24 and this is having a dimension of 16, okay. All these three steps are having a dimension of 16. However it is there in the front view, we are showing the dimension, okay. So dimension of, okay, 16 we should mention, okay. So we will draw project the lines here. We will draw the projection lines downward to draw the top view, because we know that these things are occurring in collinear. Okay, now we see the top view, so which is looking from the top. So from the top view we are able to see, okay, we are able to see this one. I am going to shade it with the straight lines here, okay. This face it is visible from the top view. By looking from the top view we are able to see this one, okay. I'm just shading it with the straight line here, okay, and this face also visible from the top view, okay. Okay, this is what it is visible. You can see, so it is having a length of 104 and then it is having a width of 72. 100 by 72 we should construct a rectangle here. First I will construct that 100 and then I will take 72, okay. So 104 we already have it here, 104 already we have it here. So you can just draw a line, okay. So draw the lines straight so that we get the exact dimensions, okay. Make sure you draw the straight lines. So 104, draw one line and then another the width we should have it here, that is 72. So we'll erase this, okay. Okay, so you can show the dimensions. So one side we know it is 104 and the other side we have it is 72. We show the dimensions here, okay. So it is having a dimension of 72. Now we can see, so we will take up
that. Okay, you can see it is like L shape we should get. Okay, first I will construct that L shape. You can see both the sides are having a space of exactly 24, so we will mark that first. Okay, 24, exactly 24 you can mark it. Okay, here also you can mark for 24. Okay, then draw lines here, so where they are intersecting we get the L shape here. Okay, the L shape is done. Okay, now you can see each of these rectangular faces having the dimension of again 24, so we can mention it. So it is 24. Okay, so this completes the top view, so we should dark it. Okay, now we can mention dimensions here. So each of these top face having dimension of 24. Now we have to draw the side view. You can see like side view we should construct. Okay, so you can see this is what I will be shading that with the help of dots, the side view. Okay, that we will get a clear understanding of it, how to do that. Okay, so you can see adjacent to the front view we have the side view. Okay, I'll be drawing the projection lines here. Okay, in order to connect the side view with the top view, we should construct the 45-degree angle line. So this concept you all know it. To connecting the top view with respect to side view, we should construct the 45-degree angle line at the intersection of x5 and x1 y1. I'll be placing the protractor and marking for angle 45 degree. Now draw an angle line passing through this 45 degree. Draw a straight line. Okay, so this having an angle of 45 degree. Okay, now project the lines from top view till it touches the 45 degree angle. Okay, you can see in this problem there is a cube given. Dimension 40 is resting on HP with its base on HP such that one of its vertical face inclined at 30 degree to VP. That means we have to draw 30 degree. Then we have to place the square of dimension 40 on it. It is cut by a section plane perpendicular to VP inclined to HP at an angle of 45 degree. And it is passing exactly at the midpoint. You can see if the length it is 40, so we have to take 20. Then midpoint we have to draw 45 degree section plane here. And we need to draw the development of the lower lateral surface of the cube. So first we will be constructing an XY line. So here XY line you can take the thickness, either you can take 0.25 or 0.13, no problem. Then you can mention XY line VP HP because it is in first quadrant. Okay, you can mention that. Write XY and VP HP because this is in first quadrant. So in the development also we are using the first quadrant only. Now you draw an angle line. So here you should draw an angle line for 30 degree. So 30 degree means below the XY line you should give an angle of minus 150. Okay, 150 if you give, the angle you get it here 30 degree. You can measure the angle by using angle between command. Okay, so you will get the angle 30 degree. Now you have to take the square of dimension 40, and then we have to place with respect to that vertical edge. So you can give the width and height same, that is like using rectangle by center command, width 40 and height also 40. the angle you can give, that is 45 degree, so that it is easy for us. So when we place it on this 30 degree angle point, now we select this and go to move command and select the end point here, and then place it on this angle line. Okay, and then go to rotate, and then again you select this whole thing, because this entire thing you have to place it. So select the again end point from one end to another end, and then place it on the angle line. Okay, now after this, so we can draw the front view of it. So front view also having 40 mm dimension, because it is a prism. So we can write the naming for it, A, B, C, D. Only top face notations we can write. Okay, we're not writing all the face here. We can show the dimension here. It is 40 mm. Now we can project the line. From the end points. Okay. Straight projection lines you need to draw. Okay, you can zoom in and check it. Sometimes you are unable to do it. You can zoom in and you can do it. Okay, now you can see the height also, it is 40 mm. So we will be constructing for height of 40. Mention it. Okay, you need to draw exactly for 40 mm here. Then you can join. Okay, show the dimension. Can give the namings here, that is A, B, C, D, the vertical edges. Okay, now you can see here we have to draw an axis. So for that I'll be drawing the thin lines here, that is diagonal lines, to find out the center. Okay, and then I will draw an axis in the front view also. So I will draw a thin line here because it is a prism. So cube is one of the prisms. So remember it, the inside lines we are drawing, it should be thin lines. Okay, it should be thin lines. You can mention it as O, and then you project it upward. Okay, and then from there you can draw a axis line here. Okay, okay, now exactly at the midpoint I'll be splitting this axis line so that we'll get the midpoint of the axis, because we have to draw an angle line exactly at the middle point of it. So we need to split it exactly at the half here. Use the split command, click on the axis and click on the midpoint. So it will get split into two halves. You can show the dimension for the lower part, so it will be exactly 20 mm. Okay, now you take a line, section plane, we have to draw an angle line for an angle of 45 degree here. Okay, you can give the angle 45 degree, enter, then you just draw a straight line. So we need to draw an angle line. Now using extend to next command, we can extend the same section plane downward also.
Okay, so it is extended. Now you can show the angle. You can see that we have done. Now I'll be darkening the retained cut portion. Remaining cut portion we should make it dark. Okay, the upper part of it I'll be making it as a thin. Okay, you can see wherever the section plane has been cutted, from there I'll be drawing a projection line downward. Okay, projection line downward I'll be drawing it. From there, wherever the section plane we are having it, we are not going to draw. Where we don't have the vertical line projecting downward, in those cases I am drawing a straight line here. Okay, vertically downward. Okay, now the upper cut part will make it as thin line. Okay, lower part we should make it as a thick line. Okay, so you can again split if it is not splitted properly, you can split it and make that upper part, because we need to draw the development of the lower portion, so we should make sure that lower part should be in dark. Okay, now you can give the numericals number where we have cutted the section plane. Okay, this is where actually cutting started, so I'll mentioning this as 1, and it is occurring in between the vertical edges of A and B, so this is 1, and I'll mention this is 2, so the point number 2, it is exactly occurring at the end B, and then point number 3, so point number 3 we are getting exactly in between B and C, that is your point number 3. If we have drawn in a straight line projecting downward, you can see the point number 3 we are getting in between B and C. Okay, and that is our point number 5, so you can mention it. So this is 3, and this is 4, and this is 5. Okay, so 5 we are getting exactly on the vertical edge D here. Now we have to draw the development of this. You can see this, and this is exactly 1. Now we can see in this top view I am going to measure this length. In order to measure it, before that I am going to split it to the exact length, so that we can able to measure it, and the same length we can cut it in the development part. Okay, using smart dimensions you can able to measure the dimension of it. Measure exactly the length which we have cut it. You can see in both the cases we are getting exactly 8.45 and 14.64. Okay, so now we draw the development of this. We'll be drawing a parallel line, a thin line here. Okay, a straight line. We'll draw a vertical line here. Now using offset command, I'll be taking 4 faces here at a distance of 40. Okay, from that vertical edge I'll be considering a distance of 40, enter. So the wrong side I have considered. You need to consider on the right side. Okay, 40, enter, click OK, and then you get the 4 faces here. Now we can mention the naming for it. It is capital A, capital B, capital C, capital D, and capital A. And now we can see here we need to mention this wherever we cutted the section plane with the number, we should mention from A to 1 on the line AB, it is 14.64. So I'll be taking arc by center point from the A point. I'll be measuring the length of 14.64 and cutting the arc. So cutting the arc, this is your point number 1. Okay, now we can see point number 2, we're getting exactly on the vertical edge B here. So for that I'll be drawing a horizontal line, so till here B. So this is the point number 2. Okay, and now for the point C,